Okay, here's homework number 6. And this is number 1. Okay, so this is how I'm going to do it. I'm going to say, unless there's something specific, like for example, Judy, for example, said, hey, I want to see the syntax or whatever for the lease, right? However, I'm going to go for part A, right? Did everyone get the profit function correctly? So part 1, right? You had to realize you use all that information so that you can get the profit function, and it equals whatever the answer was there. Who needs to see that?
I like to see that.
All right, cool. So then let me, you know what, I'm just going to scroll to the answers really quick and then pull that up so I don't make any mistakes. Give me 1 second. I'm just going to open a different document to view. There's a book template. And then I'm going to go to the end in the appendix section. Yeah, because I'm not going to do it from scratch if I already have the answers here. So just hang on one quick moment and then we'll do this. Additional practice. All right, cool. Here we go. All right. So the numbers were, let me just erase this right now. All right. So slope, most people should be familiar with this. And this was the setup right here, $200, $95, and $250 and 100. 250 minus 100. And then you get a slope of, what is that, 0.07. And then you move over to y minus y1 equals mx minus x1. Remember, as I always mention in class, is that if you have a strong algebraic background where you use possibly, and I'm just going to write in the corner here so it doesn't confuse people, you use the actual slope-intercept form, and then you plug in the numbers and you solve for b, and then you replug it in again, and that's how you learned it, like I did in algebra, and you just remembered it that way, and you just feel the most comfortable doing that. You can keep on doing that. What I have right here in purple is called, again, point slope formula, and that is more so for when you have either a shaky algebraic background or you haven't done it in a long time and you need just some way to streamline it to understand it. So here I'm going to plug in these smaller points as well as the slope, right? So that goes here. 100 is, nope, there, and this one is here. So this implies that y minus, what is that, 95 equals 0.7 x minus 100. Okay, so first mistake students do here is they forget to distribute this part right here, right? Because then it becomes y minus 95 equals 0.7x minus 70, and then you add the 95 over, and that's how you get the cost function that's in the, what do you call it, in the answer or appendix section. So let me just write that out really quick, 0.7x plus 25. So there's that, but remember, we don't use this. It's just to help us find the profit function. Remember, revenue is just whatever number I gave there, which was 1.25x. And then the second mistake students generally make is that they remember that these are the difference right here, but they forget to distribute the negative as well. So let me just write that out really quick. 1.25x minus, if it helps, put it in parentheses so that it reminds you to distribute the negative, 7x plus 25. So the second mistake students generally make is right here. They forget to distribute that. Again, that's the algebra behind it, but if you want to help yourself, just remember it's the difference between the x's right there, and then it's just the opposite sign right there of whatever number it is. Number stays the same, but opposite sign, which is always supposed to be negative. Okay, so this part goes into your model right here. So those are the two pitfalls or traps that students generally run into. They forget to distribute the first time around when they're constructing the cost function, or they forget to distribute when they're making the profit function. What questions there? All right, for the lease, right? Hopefully, whether it was just Judy or anyone else for that matter, I'm going to write the equation with the numbers plugged in. Just give me a yes or no after give me a second to write this first, of course. If you have the setup correctly, if the setup is correct, then I can write out the syntax as well. 1 minus 1 plus 0.05. This is over 12, and this is for how many years? 30, so that's negative 360. So those that were concerned with the lease, is that the setup you were able to write down on paper pencil? Now, if the answer is yes, or you don't want to say anything, that's cool. That means you have everything set up correctly, then it was a calculated issue. If it was a calculated issue, here is the syntax for that. Where can I write this? I'll write it here. Right, you're going to do this in 2 steps. So step 1, just go 1 million times 0.05 divided by 12, and then equal sign. Step 2, you're going to do a double parentheses, but before, no, I forgot something. Gotta have the divide symbol first. Divide, then double parentheses. But remember, the double parentheses are not back to back, right? They are 1 minus, and then the second parentheses there. 1 plus 0.05 divided by 12. Close your parentheses. Raise to negative 360. Close your parentheses and equal sign. So anyone that was having issues with arriving at the answer for the lease, or any of them for that matter, should be taking the opportunity right now, retyping it in, right? This is where I would walk around and check with everyone, make sure they're okay, and you give me the yes or no, or you figure out what's wrong. So I'll give about 30 seconds or so to do that. Ooh. And if you're already getting everything correct, right, keep in mind what other questions you have for number 2, for example. Because most of the questions are number 1 right now. Now, the questions I saw also that your classmates are saying like, hey, I'm having trouble, were primarily the first 2, okay? So if no one says anything else about parts C and D, right, to construct the model, I'm gonna jump straight into the follow-up questions, okay? All right,
Sorry.
Oops, sorry. Nope, that was my fault. Go ahead.
My only question is, of the model I understood, I just didn't understand one of the numbers that was in there and where it came from.
Oh, which part was that?
It's already like at part D when you have to, after you do the deposits of the 10%, that you
Correct.
have to set the model.
Right.
I got the general overview, but I don't know where the 0.90 came from.
Perfect. Okay, so that's the algebra for the model itself. Yep, I can take care of that, no problem. Anyone else talking? Let me scroll up just a bit right there. Anyone else in terms of the parts or the components of the model? for now at least. If we end up backtracking, we have backtrack, that's fine. Go ahead, sorry.
Number one, for part C, I just wasn't sure how you figured out how to, like, if it was a one-time deposit, because I was like confused on on which formula to use.
That's fine, okay, I can explain that really quick. All right, with letter C, this is where you'll see me purposefully get a little quote unquote vague. This is part C right here. Okay, here's the key kicker. When we read this, and if you don't have it in front of you, that's fine. I'm gonna read it out loud really quick right now. It says you want to make $2 million for an account paying 7 5/8% compounded weekly for 25 years. So hopefully you're reading that and you go, compound period, 52, right, for weekly. And it says you want to make, so you know that there's some future-esque aspect of it. Now here's the thing, right? In the past, like way long in the past, right? I said that the compounding period for the most part, if not every time, has to match the frequency of deposits. So the first thing you might think is, okay, he said compounded weekly, is it one time or multiple times? And then you go, well, he didn't say whether it's one time or not, or a single time, or once, or any notion of that, which is fair, I didn't. However, what you should know is also, so I'll say first step, or first aspect, okay? No single notion, right? Or once. Okay? Or I guess I should say no apparent. However, when we read this, it definitely says, definitely, no recurrence. Because for it to be an annuity, right, if you remember from the second exam, there must be some kind of phrase stating, oh, multiple deposits with weekly deposits, depositing every week or whatever the case may be, right? The only exception to that rule is when I say lease, because we know that leases are paid off per month. At least that's how I establish it in class, right? That if you have a lease, and if you're going to pay it off all in one sum, why would you borrow money, right? If you're buying from me $1 million home, right, and you have $1 million, you're going to buy the $1 million, right? Because the moment you borrow that money from the bank, you have to pay interest on top of it, right? And nobody wants to do that. So from here moving forward, you'll start seeing these problems, whether when we first are introducing them, yeah, I was very explicit in terms of the one time, the single time, the whatever. But now I'm having you dig a little bit deeper to remember what are the core differences, right? So for part C, it may look like, oh, I'm not sure, it's future, it could be one time or multiple times. So yeah, I didn't say explicitly one time. However, there is zero indication that there's multiple deposits. So it's safe, at least for this class, to assume, since this is here, since this is not present, we can assume this. The difference also is that if I said the same exact problem, but I said compound continuously, you know for a fact that it's not multiple, because we haven't learned anything that encompasses a multiple payment that is also compounded continuously. Compounded continuously will always be single deposit. So hopefully, without going too much into a circular motion, this defines it very well. And if you read any of the other examples, the homework problems, as well as the additional practice sample final problems, you'll see that's the case, right? If it's multiple, it definitely has to be an annuity. If there's no notion of multiple, it's a one time. Is that okay?
Yeah, that makes sense.
All right, cool. For part D, which I know that was asked, the 10% of the profit function, I'm just gonna write that down with it without explaining too much, right? 10% of profit, 10% of profit translates to 0.1 of the profit function, okay? Now, in terms of the model, how did we get it where I had that 0.90, right? So let me just write it out this way. I'm gonna write it in a mix. So your model looks like this. Yeah, I'll skip the new page here. I'm going to write the model with just the numbers. It's actually going to be a combo. I'm going to write the profit function with P of X, because you all know this, but I'll write out the numbers. So minus, oh, what is this? 5,368.22, and then minus that one-time deposit, which is 297,688.82. Okay, now watch this. Now you got to do that 10%, right? I'm going to do minus 0.1, and then I'll put the profit in purple again. Now, the question was, how did we get 0.9, right? And by the way, before I move on, don't write this down, but if you had written out the whole 0.5x minus 25, right? And then wrote this 0.1 times 0.55x minus 25, right? And you would have written them all out, distributed everything correctly, as well as making sure that your plus and your minus signs are correct when you're solving for the break even, setting this equal to $0, you would have gotten the answer absolutely correct. It just would have been more tedious because you had to worry about this in the front and also this distribution in the back. And the fact that this is a negative right there. So these would become negative, but then this would become positive, and that's how your answer will become off by a little bit. So I've had students have that happen before. They'll remember to distribute the negative correctly right there, that I keep on scribbling here, right? Because this is a negative 0.1. I'm talking about the back portion here in light blue. And then all of a sudden you have to make sure you change that to a positive right there as well. So that gets a little hairy as well. I'm gonna erase that right now. But I am going to note that if you had done it that way and you managed to not make any little mistakes and everything of that nature, you would have gotten the answer correct. Now, moving back to the 0.9, I just see this because it's a lot easier. I'm also going to use light blue as well. Here, we have how many P of X's? We have 0.1 P of X's. In the front, how many P of X's do we have? We have 1, right? More specifically, 1 over, don't do that. There we go. Okay, more specifically, oh, come on. There we go. Okay, more specifically, we have a single P of X, where we have 0.1 PX's, and you have 1 whole P of X. When you subtract them, you get 0.9 PX's left. Now, if I just said that and you're like, what the hell are you talking about? Here's a better way to think of it. 0.1 is the same thing as 1/10, right? Well, what's the number, the invisible number in front of P of X? That's 1 over 1. But you can't combine P of X's until you have a common denominator. So how about 10 over 10? Because that's the same thing as 1. So what's 10 over 10 P of X minus 1 over 10 P of X? Well, that's 9 over 10 P of X. 9 over 10 is 0.9, right? So that's where I got the 0.9. It condenses the variables, or in this case, the profit function together to make it easier to understand. And then that's where that comes from for the whole 0.9 P of X. The numbers in black stay the same. So hopefully that answers the question right there. It also will help you answer the question in terms of the break even for the model, right? So I remember I saw question 1 for break even, and this is the kicker, right? What's the point of break even? You set $0 equal to your model so that you can find X objects, right? So you don't want to give me the answer, then all of a sudden give me dollars at the end because you use $0 at the beginning. Okay, I'm gonna streamline this a little bit. I'm gonna go straight into the $0. and I'm going to already distribute that 0.9, okay? So 0.9 should be, I already forgot this, 0.9 times 0.55, yeah, is 0.0495. You know what, let me write this in purple so you can see the distribution. 0.495x, right? And then that's times 25, which becomes minus 22.5. So that's after distributing the 0.9 to the profit function. But then the rest of these numbers are the same, right? 5, 3, 6, 8, 22 minus 2, 9, 7, 6, 8, 8, 82. So you take, we'll use green now, right? You take this number, this number, this number, add them all together, add them to the other side, and then divide by 0.495, and then that will give you your answer. However, I have a complete whole number answer of x equals 612,282 marshmallows because we have to round up, right? You round up to next whole number. Next whole number, right? What questions there, if any? Actually, you know what? Let me scroll down so people could see the model as well. And then remember, this is, you can consider your base model as well, right? I don't say that often, but maybe I do, I'm not sure. But that's your starting point, right? That's your model, and then we move forward from there. Give it a couple more seconds just in case if people need to catch up or ask. Okay, this is great because this segues into our second question, right? Someone asked, oops, wrong color. Someone asked, oh, what about question 2 or follow-up question 2 from the model? And I asked, let me see the exact phrasing I used here. How does the model change from the first month to the second month? Now remember, your profit is your only channel of getting money in, right? So that means if you're looking at the base model that I wrote up here for you, right? And whether you use the P of X minus 0.1 P of X, or you combine them together to get the 0.9, it doesn't matter, both are correct. It's just, again, your preferred method. You know that carries over. It carries over because, let me use a different color here. This carries over because I haven't told you that you're making profit in a different manner, right? If I would have said something. So profit function carries over. You still have to make money some way, somehow, right? The lease is right here, right? So people that were asking about the lease, whether it was just Judy or Judy and company, right? You're paying that every month. That's not going anywhere. So that comes down here as well. So minus $5,368.22. Now this is a kicker. I'm sorry I didn't recognize whoever's voice that was, but when they asked for part C, that's this one right here, how do we know whether that's one time or not? Well, remember, it didn't tell you that there were multiple payments, deposits, whatever you want to call it. So it must be one time. If it was one time for the first month, that means it doesn't follow us for the second month. So you think, oh, I got to bring this over. And then all of a sudden it's like, nope, big no-no. So it actually is just this for your second month's model right here, right? If you wanted to, for whatever reason, again, you could have put the 0.1 P of X here at the end, but if you do that, you got to make sure you take off the 0.9 in front right there. So let me just erase those really quick. But either way, that either expression would have been correct, okay? And then what did part C ask for? Yeah. I asked you to manipulate the model based on the change of the revenue function. All right, cool. Let me pause one more time for a moment there so people can soak that in. And then do we need to see what do you call it? Part C. And then if not, what other questions for number 1 as a whole? And then I'll open it to number 2. Let me flip it over and see if anyone has typed out questions. Part 2, the leading question. That's fine. Okay, cool. I inadvertently answered that for you as well. So hopefully that was cool for everyone else. I should probably take roll really quick right now. All right, so that's good for number 1, I hope. No one's saying anything, so that's that. I saw Leah, Erica here. I don't see Erica. I saw Sophia, I saw Jocelyn, I saw Judy, I saw Janin.
Hello, can you hear me?
Yep, go ahead, Sarah.
My mic wasn't working for a second.
No, that's fine.
I'm sorry, I was trying to say that I still had a question for part C.
Yeah, please.
Can you just go through it really quick? How I understand how you got the R of X, just when you said you reduced it by 0.25, what did you mean by that?
Absolutely. Asia, let me just grab everyone really quick here,
Yeah,
sorry.
sure.
It's funny because on Blackboard, your guys' names are in, of course, alphabetical order by last name, but Zoom is just giving it to me in alphabetical first name, so that's kind of lame. Is Greg here? I don't see Greg.
Professor,
It's Maxwell. Yeah, go ahead.
can you also like go into the thought process of like deciding, because at first I used for numbers for letter C, question number
Right.
1, I first
Right.
the present value equation, and I was trying to find R, and then when I finished that, I was like, wait, this doesn't seem right because I got $512. So I was like, I went to the appendix section. I saw that you were trying to find P.
Correct.
I didn't understand like what the thought process of knowing that I needed to use that formula.
All right, cool. So I'm not sure if you caught it the first time around. I'm talking about right here at part C. Wait, who just left right now? It makes a little sound when anybody exits, so hopefully it wasn't someone that was asking about it. All right, so one more time. If anyone that didn't catch it, it was this part right here about part C, right? So I'm gonna draw a little light blue asterisk there. Okay, so this is, the short answer is, if it doesn't say multiple deposits, it's safe to assume that's a single deposit. That's the short answer. The more concrete answer in terms of how you go about it, right, is that here in green, I said that most people would notice that it's a compound period problem, which is absolutely true, and the fact that it has some future-esque amount about it because it says you want to make $2 million.
Yeah.
You may notice that it will say no notion of a single deposit or a one-time apparent deposit or a one-time payment, whatever you want to call it, right? Whatever the point is that it appears that there's no one-time cents in there. And you're like, okay, cool. That may be the case. I'm not sure. But then the moment that you go, oh, there's definitely no notion of recurrence, right? Because from our second exam, I had that question there. How do you know if it's an annuity? There has to be some notion of multiple payments, multiple deposits, or the deposits have to match the compounding period. So in this case, there's 52. So I would have said weekly deposits, or whatever you want to call it. And then now in purple, I said, since this is not present, right? Because it has to be there to assume annuity, it's safe to assume that it's a single time deposit.
Okay.
And the last thing I wanted to say about that was that if we had the same exact problem, right? You want to make $2 million in account paying 7.58%, but then all of a sudden it said compound continuously, it's that same notion, right? You know that there's no multiple deposit, but you absolutely know that it's a one-time, because with continuously, there is no annuity. We haven't learned, and I'm not sure personally whether it exists of an annuity with something that's compound continuously. But again, the short answer to wrap that up is that if it does not say anything about multiple anything, whether it's monthly deposit, weekly deposit, whatever deposit, it's safe to assume that it is a one-time thing. The exception to that rule is, of course, a lease. A lease, I won't say multiple deposits, but you all hopefully know, because at one point you paid rent, or you're paying something off per month, or you're paying off, I don't know, a credit card or something. As long as there's a balance, there's always some kind of recurring payment. Is that clear now?
Yeah.
All right, perfect. So that's good for Maeve. And then the last part C, that Seraph was asking about, this is the way you want to go about it. There's the long way and the short way, right? The way when I first was talking about this question, right? So part C, let me read it out. Question 3, let me read it out really quick. It says, suppose the third month marshmallows are no longer popular. They're overtaken by chocolates. Now you consider to sell each marshmallow produced at $1. So Sarah said that, hey, she already understands that means that the revenue function went from, you know what, let me match the color I used at the beginning. I used navy, so 1.25x. Okay, so we're talking about the revenue function here. Original revenue function is 1.25x. And she, as well as I'm sure many of you, have understood that the reduction was this. Now 1.00x. Where did I get the 1? It was the $1 in the problem. How did you know it was the revenue function? Because I said now you have considered to sell each marshmallow produced at $1. So see, even though we're talking about marshmallows or whatever the hell we're talking about, I still use that same phrasing. So it's a nice little hint for you all. Okay. And then again, this is just story ad lib, but the contractors are willing to still produce marshmallows at the same rate. So that means basically don't change your cost function. And now I ask, how does your model change for the third month? So the long answer is to realize that you went from $1.25 to $1, regular dollar, I'm sorry. So that means that your profit function now is $1 x minus what you had in the cost function, right? And remember, if you don't remember the cost function, it was the whole 0.7x plus 25. So now your new profit function will be P of x equals, what is that? Should be 0.3x minus 25. Okay, so that's that. If you, wait, make sure I did that right. Yeah, 0.3x minus 25. Okay, so if you did it that way, perfect. That's the quote unquote long way to think about it, because I told you to change the revenue, and then you're supposed to realize, oh, if the revenue has changed, the profit in consequence or in ramification has to change as well. So you have a new profit function. The statement that I said that it reduces by 25 cents is this. So this is a little bit more, I guess you could say clever. It's not necessarily any smarter. It's just what you pick up. What is the reduction? And this is for anybody. This is for the entire class. What is the reduction in the revenue function right there? What's the difference?
0.25.
25 cents, right? Mm-hmm. So if the revenue changed by 25 cents, what does that mean for the profit? It has to also
reduce by 25 cents.
it's also reduced by 25%. I'm sorry, not percent, 25 cents. Yes, that is absolutely correct. So the revenue shows you the algebra as in terms of cranking it out. But then when you look, what happens? You have a subtraction of what was the original 1.25x minus the cost function. And then now all of a sudden you have a 1.0x minus the cost function. See how the cost function doesn't change? Since the cost function doesn't change, this reduction that I wrote in pink right here of 25 cents, you know it's going to follow through in this as well for the profit function in 25 cents as well. So that's what I meant by saying, how did I say this? This also means the profit function reduces by 25 cents. Yeah, you know what? I should probably rephrase that. It's not the profit function itself. It's more like the slope of the profit function. So let me say that a little bit clearer. If each marshmallow produces now $1, that implies the revenue function. Well, this also means that the profit function variable, profit function, where'd it go? This also means that the slope of the profit function reduces by 25 cents. In other words, the new profit function is blah, 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 blah. This also applies the overall model has a lower generator output in terms of income. That last sentence, excuse me, if anyone was curious, obviously if we make 1 million marshmallows the first month, we have some kind of outcome. And then for the second month, you make less marshmallows, right? You're gonna lose a little bit of money. Also, the other thing is that if you make 2 million marshmallows, but all of a sudden your profit function decreases, but you make more physical money, those are two different things, right? So when I say, this is just the last bit here I'm saying, when I say overall income reduced, that is not the same as actual or physical profit, right? Because when you go from a profit function of 0.7 to 0.3, the machinery, if you will, quote unquote, right? The variable itself, it gets multiplied by a smaller number, right? However, if you made 1 million marshmallows the first month, and all of a sudden you're able to sell all 2 million marshmallows that were made and sold in the second month, obviously your physical profit is higher because the number itself is a lot higher, right? But when you say the overall income is reduced or the profit function is reduced in terms of generating profits, it means that it's scaled down, right? So I guess the easiest way to think of it is that if you make $10 an hour, right, and you work 40 hours, and all of a sudden, for some reason, the next month, you go, you know what, I'm gonna make $1 an hour, right? Super reduced, super scaled down. But if you work 1 million hours, obviously you're gonna make more money because the output in total is more than what it was the previous month. So that's just another extra tidbit right there where I'm saying overall income reduced, that's what I mean, or overall profit function technically. You change that. Overall profit function reduced, but that's not the same as actual physical profit, because if you're reduced, then you work more, you make more in this case, then you make more money, right? And more physical money doesn't always mean that, you know, whatever the case may be. Hopefully that makes sense. All right. I think we killed question 1 now. It's like just beaten to death. Let me make sure there's no more questions here that people wrote in the chat. All right, cool. What other questions for number 2 now, if any? The only thing that I want you to be careful with number 2 is that when you're doing that problem is you're supposed to realize that what the heck are my problems? Oh, here we go, page 30. The only thing that you had to be careful with was Maybe some of you got confused with Part D where it says you hired an intern that you pay twice a month for social media presence. Sure, they're paid twice a month, but whatever they're paid that twice a month, you can reorganize it to a single variable, right? So for example, if I get paid $100 twice a month, right? That's kind of saying 2 times 100. That's the same thing as just say $200, but once a month, right? We're not worrying about the nitty gritty details of, hey, make sure your payroll is working on time so that this person gets paid $100 every twice a month, you know, at the middle of the month and at the end of the month. It's like, we're not worried about those type of logistics. We just know that $200 has to be allocated to this intern at the end of the month, by the end of the month. So in this case, you hired an intern that you pay twice a month for social media presence. I said it was okay whether you use a different variable, like maybe I for intern, or you use 2i, which represents twice the intern's payment. But either way, it boils down to a single variable. Everything else should be straightforward, flat, monthly deposits. And so you can read it too here, number 2, when I'm talking about, hey, you monthly deposits, whatever the case may be, or even part 2 for the follow-up questions, right? It says, suppose you make extra money, you want to deposit an amount for the second month, right? And I told you it's compound daily, but I didn't tell you that you're depositing every month from there on forward. So that's another example of how follow-up question number 2, in number 2, it has compound period in there, and you might go, well, wait a second, is it one time or many times? And it reads like either, but you have to realize that it doesn't say a single thing about depositing on a frequent basis. So it's okay to assume that's one time, right? I probably talked too much there as well. What are we at right now? An hour in for homework? Okay, to give you guys some type of scaling or time notion, depending on how many questions are asked or if people are understanding as a whole, the first hour is, of course, always attributed to going over homework problems, but I normally am able to do it in 30 to 45 minutes, depending on how the class is and everything. So we're right on time, more or less. So there's not that. It's when we start going over homework, for example, and then all of a sudden we're well past an hour and a half or an hour, that I go, okay, people aren't understanding this. And then that's when I will crank it up where it's like, okay, we didn't get to go over enough material. We have to meet on Friday, mandatory type of thing. But right now we're still okay on time. So it also depends on you all as a class as well. All right, last chance, at least for today. What other questions for homework? Because if not, then we're going to talk about summations and stuff. Part C for question 2, can you please go over? Yeah, sure thing. Part C for question 2. You're talking about, Alexa, the component part C to make the model, or you're asking for question number 3? You can type your response again. I'm pretty sure you meant part C. Yeah, component part. Okay, thank you. Okay, so this is for number 2 now.
Wait, Professor?
Yeah, go ahead.
Sorry, I missed last week. We have to upload our homework from now on?
Yes.
Okay, I'll do that. Thank you.
No problem. Right, if people trickled in late, I'll talk about homework again before we end class today, so don't worry.
Thank you.
Okay. This is, all right, number 2. And this is part C. Okay, so Alexa, I'm not sure what exactly you had a question on. So what I'm gonna do for you right now is just write out the equation with the numbers really quick. You wanna make monthly deposits, so you should have $500,000. So I'll give you a brief moment, and then you're gonna let me know, as well as anyone else, $500,000 at 0.0515. If it was, hey, I didn't use the right formula, or hey, I need to see the syntax. 1 plus 0.0515 minus 1, And then this is per month, right? And it's in 30 years. Okay, so that's 12, 12, positive 360. So how does that look? Like what you have?
Yeah, the cake is put into the calculator wrong. I don't think I
All right,
used the double
cool.
parentheses with the problem. Thank you.
Okay, so if you want, do you want me to write out the syntax or you're good?
You could, if you can write it out, that'd be good.
Yeah, I'll do it really quick, don't worry.
Thank you.
So syntax, remember, you're welcome, is in 2 steps here. That would be the easiest. I forget if you have a regular calculator or not. For everyone, for that matter, you want to use a regular calculator the best that you can. If not, you can go into a Google web page and just type out. But then it's hard because you can't really recall the previous answer depending on how you do it. So nope, I almost forgot it again. So divide symbol, parentheses. So here, this is what I was mentioning earlier. The double parentheses are back to back in a future value problem. So 515 divided by 12, close parentheses, positive exponent this time, 360 minus 1, close parentheses, equal sign. All right, so feel free, anyone that needs to rehash that, do that. Otherwise, ouch. If there's nothing else or you're trying to brainstorm, another question for number 2, just feel free to shout that out now. Otherwise, we're gonna move on to the summation aspect. Oh, excuse me. We okay? Oh my goodness, the market's all over the place. Anyone's buying stock in this time? I would say hold off a little bit longer. Looks like the market as a whole is in for another dip. Carnival's still down. Banks are going down. Pharmaceutical is still, and food is still up, except for Kellogg for some reason. And Kraft Foods. Interesting.
Just
All
have
right,
a
cool.
quick overview question.
Yes, please.
Is this the last that we're seeing of like the mathematical modeling? We're going straight into whatever you were. I forgot which subject you said before.
No, it's okay. The mathematical modeling is from here moving forward until the final. And this little tidbit right now that we're going to do about summations, it's going to be incorporated into the mathematical modeling.
Okay. Okay.
It's another form of generating income, in other words, because long story short, when I was learning modeling the first time at Columbia, it was interesting. And then when I started teaching at FIT years ago, you know, you have this class, it's cute. You're like, oh, mathematical modeling and business application. So I can really, you know, take what I learned from my studies and apply it here, only to find out the class is super basic. You know, like, yeah, we learn models like here, linear, example, exponential, it can model the situation, but it's not like a real model. So this is nice because this is a living, breathing mechanism, right? Or template that are models, are these base models. And then when you move forward, moving month to month, you can adjust it as necessary. So it really follows you, if you will. It's crafted for you, whether it's like personal finances, business finances. I mean, I'm sure we can make up a personal one, but it's kind of hard because people, maybe they're not working on a regular basis or it doesn't seem very meaningful, but the ones that I do are always like business like, if you will. But we can try personal ones if people need a little bit more down to earth example of how you can, because it's almost like personal finances, except I'm really ramping up the mathematics with it. That's all.
I see. Okay.
Mm-hmm. So yeah, this is, and of course that was open for the entire class. If you want to see, so for example, say Friday, for example, for those that want to chime in and you go, hey, I want to see a mathematical model, but let's do something way more realistic, right? Pick numbers from real life, pick my current salary or hourly wage if you were working without the virus, and, you know, pick a bank account that has a real, what do you call it? Interest rate, and then maybe tell me a couple credit cards, and yeah, we can definitely do that, and it'll maybe even make it more relatable. Now obviously people aren't going to sit around and do mathematical models like this. They're just going to go to Excel and pick out a, what do you call it, how can I think of the word right now, like a budget sheet. There you go, thank you. Like some kind of template or budget sheet, and then you just punch in the numbers when you're spending, and you just got to pick, okay, don't spend this much or allocate only this much, and then, you know, this much comes in. Even then, the budget sheets just show you how much you're spending. It doesn't show you how much money is coming in as well, unless you incorporate as such. So, you know, little things like that. So think about that. If that's something that interests you, just send me an email or let me know before the end of class. And then what I'll do is when I type out the next problem in the Google Doc sheet, I'll pick something that's realistic and then we'll go from there, okay? As for summations, right, the reason I'm bringing it up is when I was learning mathematical modeling, I had a colleague, friend, classmate, everything, super brilliant. And I love the way that he did one of the problems, and it has to do with choosing the best thing, and it has to do with picking a painting. I used to do that as an example for modeling to introduce it. And then I just scrapped it because I don't know why. It's good. It's a good problem still. It's just I scrapped it and I just jumped right into the finance stuff out of it. So if you're curious as to what problem that is, having to pick a painting, I can talk about that briefly as well. We have time, but here's example one, right? So if you're looking at the Google Doc sheet now, so you're not looking at my textbook anymore, you're looking at the Google Doc sheet. For example number one, it says that you're the head of social media for a company, whatever company it may be, right? And research suggests for each social media post published, right? I guess I should just say for, you already social media, so you don't need to write social media again. For each post published, it will reach 2 new people the next, wait, what? Yeah, it will reach 2 new people the next day and thereafter. Suppose for the first day, and you can see that I wrote in italics there to make sure that it's like, hey, the post reaches 4 people. I'm gonna delete the word social media again. That's kind of annoying. Okay, the post reaches 4 people. How would you represent the growth in the total number of people reach? So you're reading that, right? And you're kind of going, what the hell is going on? And you can probably draw a picture to it. And that's normally what I start with first so that people can visually see, right? We're mostly visual learners, or you go from there. So say the first day, right? You start with 4 people. So you're part of some company, right? And you're going, hey, it's already April 22nd. So say you're planning for May, and May, you're gonna make a social media post, and what happens is that post reaches 4 people. So there's 1, 2, 3, and 4. Right? And then the research suggesting is, nope, that's not right. For the second day here, it says that the growth, right, it reaches 2 new people the next day. So that means assuming that all 4 people saw it, because they share it, it reaches 2 new people. So let me just take, this part's a little tedious, but let me just draw each person with a new colored pair. And last but not least, let's use a different color. Go navy here. I'll do orange. All right, so the idea is that all of a sudden you had what? You had 4 people interact with whatever said post, and because they share it, right, the expectation or the growth rate that we're looking at is going to be 2 per each of those people, and that's what I just drew there, right? Each person introduces that same post, and all of a sudden you have what now? 2, 4, 6, 8, 8 people, right? And if we did this continuing onward, 3rd day right here, what happens? Well, I'm not going to draw it for everyone, but now this single person in green, no, let's do purple. Single person here in purple, they're going to share it to 2 new people. And then the second person in purple, they're going to share it to 2 other people. So you can see that it's going to grow ridiculously fast. Okay, so then it's 2 for each person here, right? 2, 4, 6, 8, 10, 12, 14, 16. Would you agree there? Right? And then if you had a 4th day, I'm not going to draw this, but what would you assume to be the next number here? If 4 the first day, 8 the second day reaches, 16 it reaches the next day. What do we think the 4th day is?
32.
32, right? And then whoever that was, thank you for answering, first of all. And second of all, how did you get that? You multiply by?
You just multiplied by 16 by 2.
16 by 2, right? So if anyone and everyone has noticed already, right? To get over here, I'm gonna draw a nice little arc here, you multiply by 2. Multiply by 2, multiply by 2. Okay, and that's great. This is a nice, easy example. And it makes sense. It's a nice steady growth. And if I change the numbers, I'm pretty sure you guys can figure it out too. Okay, in terms of how to go about it. However, what were the numbers we were given, right? Let me write this down. We were given, oops, no, sorry. I was correct, but give yourself a little bit of space because I'm gonna write some stuff underneath this related to those numbers. So if you're writing along, skip like a couple of lines and then I'm gonna write here. We were given what? 4 and 2. So what's happening? Well, 4 is what we started with. Would we all agree? Because we saw these 4 jackals here, these 4 chuckalucks here, whatever you want to call them, right? And 2, you could think of that as, I don't know, your multiplier. Or how about growth? Right? I would say growth is a better word, right? Because you're multiplying by 2 every time, okay? Now my follow-up question is, and you don't have to answer this immediately, is how would you rewrite these numbers so that they involve a 4 and a 2, right? I'll ask that question one more time. The numbers of 4, 8, 16, 32, and so on, right? Let me erase those check marks. But this does go on, so on for forever or until however many days we want to. My question is, how would you write it, or how would you break down those numbers, 4, 8, 16, 32, so that they're representative of only 4s and 2s? So let me do an easy example for you. For 8, for example, that's like saying 4 times 2. Easy enough, right? That's 8 represented of the numbers 4 and 2. And why did I pick 4 and 2? Those are the numbers we started with, right? If you read the Google Doc, we start with 4 and research suggests that it grows by 2 every time, okay? Now, what about like say 16, right? We know the numbers that are involved with it. You know that there's a 4 there because, well, there's a 4. And you know that there's a 2 because that came from 8. And then all of a sudden we multiply by another 2. to get to 16, right? What about 32? Well, if the previous number was 16, you know that there was a 4 and a 2 and a 2, but to get to 32, you have to multiply by an additional 2. So everyone see what's happening now? The 2's are increasing exponentially, or in other words, we have to multiply by another additional 2 every time. And this one here is 4 times 2 as well, but there's a trick to here. If you have 1 2 here, and you have 2 2's here, and you have 3 2's here, how many 2's do you think you're supposed to have here then? Right? And if you don't recall, any number raised to the 0 power makes it a 1. So that's how we can get our number 4 here, but still have the same format of the no 2's, 1 2, 2 2's, or 3 2's, right? Or another way to think of this is 1 2, or 2 to the power of 1, or 2 2's, which is 2 to the power of 2, or 3 2's, which is 2 to the power of 3. So we see what's happening here? Your increasing is based on a combination of what you started with as well as what you're growing by, okay? I take the moment to define this as far as this class is concerned, at least. So I'm gonna scroll down past the picture. I'm gonna call this definition. And we're gonna call this growth representative of social media, at least for this class, right? I'm not saying this is how all social media works, but this growth representative of social media, I want to put social media in quotation marks, can be defined as ... the following. It is alpha. You could use any variable. I just started using Greek letters now because I didn't want to mix up things. Times beta, so that's the first and second letter of the Greek alphabet, to the I minus 1. So this is not a formula to memorize per se on your formula sheet. It's just involving whenever you have growth like this, where alpha, and you know what? I'll match this with what I wrote here in colors. Alpha equals, I like to describe it as the base number. So in our case, our base number, what we started with was 4, and beta is the growth rate or growth factor. I like to call it a growth factor because you're growing by a factor of 2 every time, okay? And then I just represents, not interest rate, right? We're not talking about interest rate here. This is the day or days in question. Days in question. All right, so we have number 1. I told you the what do you want to call it? Hold on, something's running out of battery here. I don't know which one it is. Yeah, anyway. We have this growing situation. You start with 4, you grow by 2. I took you through a visual take on it, a multiplying take on it, and also now an exponential version of it, right? This is our definition of it. And now, keeping that in mind, what if I asked you questions? Did I write them down in the Google Doc here? Definition, sigma notation. I'm gonna write it here really quick. to know the total number of people in the first number of days? What if I wanted to know nope, that's not what I wanted. What if I wanted to know, what if I wanted to know the total number of people in a single day? Okay, so I just added two notions there, right? So we're going to use this now and go, hey, what do I want to know? What do I want to know if, or how do I want to know if, for example, from example 1, right? Remember, we have now this 4 times 2 to the I minus 1, right? So again, I got the 4 and 2 from example 1, and I'm now writing it in this format here. And then what I just typed in the Google Doc is, what if I want to know the total number of people in the first number of days, right? What that means is that, say the first 2 days, make it super simple, right? Well, if you want the first 2 days, let me write this out, the word first 2 days, right? You would give me 4 times 2, and then now I'm going to use a different color to represent the days of 1, and then minus 1. Remember, minus 1 is part of the equation. Okay? But then I want it for the first 2 days, so you have to do this twice, right? 4 times 2. Oh, yeah, wrong color. Times 2 to the second day now, and then minus 1. See, so now that's representative of day 1 and day 2 for the first 2 days. Of course, we already know the answers here, right? So this is 4 and this is 8. But what do? How do we combine them? We add them. So the answer is 12 in this case, 12 people. And that makes sense from your picture above that I drew here, right? You got 4 little stick figures, and then you got 2, 4, 6, 8 other stick peoples. And then if you talk about the first 2 days, that's 12 people in total. Now, what if you just wanted the 10th day only? The 10th day. Well, you take the same numbers, 4 times 2, right? But the difference this time is that you just plug in a 10 and you don't have to add anything, and you just perform this calculation. I don't know what this answer is, so let me take a moment to do it really quick for you. 4 times 2 to the 9th. So that's 2,048 people. We're still talking about people here, okay? So this is how this exponential representation of this alpha times beta raised to the I minus 1 is help us to categorize this and to deliver this information in a more smoother transition with one equation or expression, right? Instead of drawing pictures like this or having to draw a sequence of numbers like 4 times 8 times 2, 4 times 2, then times 2, then times 2, then times 2, right? It gives us in a nice compact way. And then if we have to calculate for so many days or a single day, we can do it, okay? Now, since you have this understood from a visual and mathematical perspective, we can introduce the sigma notation, or in other words, the summation, right? So now imagine, if you will, that you're still in charge of social media, but then now you're going to say something like, hey, let's monetize on this. We're getting so many views, or we're getting so many likes, or we're getting so many hearts, depending whether you like Facebook, Instagram, or YouTube. or TikTok. You won't ever find me on TikTok. So I don't even know what the format's like there. So it's just one of those things that once you're a certain age, you just don't do anymore. Just like when Snapchat first came out, I was like, yeah, I'm not doing this. So whatever your preferred social media platform is, right? You want to monetize somehow. And that's how I'm bringing this into modeling, right? That you have some kind of income generator that isn't just something that we've been doing with the whole variable or linear or cost revenue profit or some kind of number. It's like this mixes it up a little bit. So this is the last formal new thing. All of you have known, I've seen a summation one time or another. It's just that the sigma notation might be a little bit different for you. But this is the last thing that we're going to do. And again, it's called sigma notation. And then we'll do one example and then we'll call it the day. Right? Sigma notation looks like this, where you have the capital letter sigma from the Greek alphabet, and then you have, it looks something like this. So I'm not going to box this in purple because this is what most mathematicians would consider the base form. And like I've said in the YouTube video as well, it's the same thing, right? You have some kind of lower limit, which is this number here. The lower limit is the same thing as your starting point. The number on top is your upper limit or your ending point. And then what I didn't go into super detail, but I can have an opportunity to say right now, is that this I right here, it's not there by mistake, and it does match these two I's, but they represent two different things. The one in purple or underneath the summation symbol is to indicate, hey, you're starting at 0, then you go up by 1 at a time. So 0, then 1, then 2, then 3, and so on and so forth. This I is just an algebraic expression. The most simplest form is to have a single I there, like you see right here. But that can develop or evolve into anything. And then I'll show you examples of that. So examples of that are something like this. We have e.g. I equals 0 n, and then maybe have something like 2 plus I squared, right? This I is an index, and it tells you, hey, plug me into your algebraic expression, whatever it may be, whatever number matches the indice, right? So if it's at 0, you plug in a 0. If it's at 1, you plug in a 1. If it's at 2, you plug in a 2, 3, plug in a 3, so on and so forth, right? If it's at 1,000,000, you plug in 1,000,000. Or if you have a different expression like that can involve more variables. So something crazy I like this, where you have I minus I squared plus I to the third, right? We're not going to take the time to do this. We'll do it in a simpler example, but you can see that starting at 0, that I, whatever it is, goes into here, here, and here, right? A simpler version of this, so that you can get you guys used to it, is something like this, where you have the summation of I. I'm going to start at 1 this time, and I'm going to go only to 3, and we're going to pick something like this, 4i. So this is a summation. You know you're going to add things up, right? That's what the sigma indicates. It indicates that you have some kind of algebraic expression, and you're going to increase or have increments increase by 1. And then whatever the result is, after you calculate, you're going to add them all up. So this is to say this whole expression right here on the left, right? This is equal to first a 4 times I. Well, what's our first I? Our first I tells us that it's 1. So you plug in your 1. You see there's nothing else to do. So you move on. You do the same exact thing. And now 1 is done, and you move to what now? You move to 2. So now you plug in a 2, for I, which is right here. And last but not least, sorry, that 4 was supposed to be black. You do it one last time because you go from 2 to 3 now. Goes in here. And you know it ends at 3 because it tells you what the upper limit here is at the top. And again, since this is the sigma notation, you know that you have to add these results after you finish calculating them. So that means that you got 4 times 1, which is 4. You got 4 times 2, which is 8. You got 4 times 3, which is 12. And then your final answer is 24. So that's how you use sigma notation, right? It's just a sum, which you've all seen before. It's just that now, since you have been introduced to it, you can have something that we've learned in the past, right? Exponential growth right here. Sure, it looks a little bit weird, but you know what's happening right here when you're using numbers. And then I'm interested in not only the growth, but the growth day over day, right? So we have what I have circled on the left, an algebraic expression, and it could be something simple like this, where it is linear, or it can be something a little bit more complicated like exponential, which you're going to see on the next example. And then the reason for summation is that I'm not interested in one calculation. I'm interested in multiple calculations day after day, okay? Before I jump to example 2, which will be the last one on the Google Doc for the day, what questions do we have here? Any transition to understand or blah, 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 this and that. Let me see if anybody's typing questions too. Oh, they are. Oh no, wait, that was Alexa earlier. Sorry. What questions up to here?
Professor, can you explain, so I don't know if you're going to go into this with the next problem, but with the,
That's fine.
with the I equals like 1, 2, 3. So
Correct.
it was like I equals 10. So
Right.
like I would think to myself, okay, so I'm going to have to go all the way up to 10 to make sure that I account for the 10 days that the people are being, right? Is that like would I use that as a signal to determine like how far I have to go with the calculating of people?
That's an awesome question. So, sorry, who was it that asked that?
Maeve.
Maeve, awesome. I should have recognized your voice. Okay, sorry I didn't. That's an awesome question. So the question, if you guys didn't catch it, because I think the audio may have been a little bit, might have been on and off and on and off, right? The question is that here we can see that it goes from 1 to 3. So it's easy to see that we go first day, second day, third day. I'm using days as an example because that's what we're going to use, but it can be for anything, 1, 2, and 3, right? The question is, for the 10th day, do we have to do in sequence 1 through 9 before you get to 10? Now, this is a great question because the next example does ask that, but I'll have you all direct at it right now because you can read it right now off the Google Doc since I don't have to rewrite it. But going into example 2, to answer that question, you can tell the difference of how I phrase the question. So if you look at the leading question, which is of course, make the model, look at number 1. It asks you, how many people are reached within the first 5 days in italics? The first 5 days means that whatever our model will look like with the summation, you have to calculate it for day 1, day 2, day 3, 4, and 5. And once you get a number for each of those days, you add them all up together. So that's how the summation works. But if you look at number 2, it asks you, how many people are reached on the 15th day? The nice thing about that is that I'm not saying the first 15 days, it's only the 15th day. That's why it's in italics right there. So when you do it that way, you actually don't need a summation. You only plug in a 15 right away for I in this case. Okay. So hopefully that answers your question, Maeve. And then for everyone else, if you're kind of going like, what the hell do you mean? Don't worry, we're gonna do it right now, okay? So before that, any other questions in terms of sigma notation in general of what's happening here, why we're learning it? Oh, I mean, you're learning it because I'm telling you to, but I'm also teaching it to you because it's another form of income, right? that we're going to learn. All right. All right, if not, think about it for a moment, but I'm going to crank out example number 2 really quick for you. And then maybe once we answer the follow-up questions, they'll answer any other questions you may have when it pertains to this. So I made this model super easy, right? I only gave you one component, right? Research suggests, and then if it wasn't a hint already, if you ever read a model and it says research suggests, wow, I'm tired. Research suggests for each published post, blah, 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 this, you know that it's a modeling problem involving a summation, okay? So you can, that's for sure. If you see a problem like this, it is safe to assume that it's a modeling problem that has a summation because I've only phrased it for you this way. There's no other way for you to learn or do something like that. So part A right here, it says that the growth factor is, what is that? 3 people the next day and thereafter. And suppose for the first day, it reaches 10. So that's your initial, right? So using what we learned, that means that you have 10 here times 3 to the I minus 1, right? But then all of a sudden, it also tells you 10 cents is made for each person the post reaches. So that means that you have to do something like this. Times 10 cents, right? Now, when you ask what the model is, since we want to worry about the summation, it looks like this. The model is the summation from starting at day 1 to however many days I may ask you, with the numbers starting with 10 growing by 3 to the I minus 1, and whatever this result is going to be multiplied by 10 cents because you make 10 cents per view. So that's your model right here, your base model. Now to answer the follow-up questions, this is exactly what Maeve was asking about, and for anyone else that was having the concern. Okay, so first question. This one is actually asking for a proper summation because your hint here is first 5 days. In other words, you're saying you don't have to be so formal when you write it out like this, but you can if it helps you. So you go summation I equals 1, but you end at 5 of 10 times 3 to the I minus 1. That means you're going to go 10 times 3, and again, I'm going to use a different color as well, to 1 minus 1 plus 10 times 3 to what comes after 1? 2 minus 1 plus what? 10 times 3 to 3 minus 1 plus 2 more. So obviously I can't ask you whether it's homework or even an exam to do this for so many numbers because it gets super tedious if you're doing this by hand. If you have a graphing calculator, there are ways to do this a lot faster. 10 times 3 to the 5 minus 1. So that's what it means by first 5 days, because you're not asking for just the first day, you're not asking just for the 5th day, you're asking for the first 5 days, day 1, 2, 3, 4, 5, right? So you do this, and I do have the calculations in advance. So this is basically asking for 10, 30, 90, 270, and then 810. And this is the same exact thing by that growth rate as whoever it was that answered at the very beginning of class. How are they changing? It's 10 to 30 by asking times 3, 30 to 90 by times 3, so on and so forth. How do we know that? That's because of the growth of that 3. That's why it's changing like that. So this is a total of what? I did this in advance. It's 1,210 people. That answers the first question of how many people there are, how much was made. You have to multiply this, remember, times 0.1. I'm not going to do it like that. You multiply this times 0.1, and this gives you how much money was made. In this case, $121. Right? So this is what it looks like, summation style. You got the model here. This thing makes you money, right? Makes you money. Makes you dollar signs. Right? So 1210 people multiplied by how much you're making, 10 cents, and it's $121. Whereas question 2 now asks you, hey, give it to me for only the, what day is it? The 15th day. So this one, it's no summation. Right? Which means that it's the 15th day. So this implies you don't need a summation. You just straight up go for 10 times 3 to the 15th minus 1, and you only do it for 15, right? No adding, no nothing, no anything of that nature. So this is equal to 47,000 or million 29,690 people. And then you take that same value and you multiply it by 0.1. This gives you how much money was made. In this case, $4 million, 782 and 969. Now, obviously, the pitfall of a summation like this is that you know that social media doesn't always grow like that from day 1 to day 15. So it's not going to keep on going up, 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 up like that. So people, they know that what? Normally when you have some kind of social media, unless it's super popular, it'll spike up really quickly, exponentially. But then of course, there'll be some new fads, some new memes, some new whatever. And then what happens is that it'll level out. So that's that. And then answers here. All right, cool. So these two questions, whether it's question 1 or question 2, you can see they're of the calculation or calculating type, right? You're not manipulating the model or doing anything in that nature. But when you look at the Google Doc and you move to questions number 3 and 4, you'll see that there is now, suppose for the second month, the growth of reach stays the same, right? So that means that 3 stays the same, but the first day, the post reached double numbers, right? In this case, 20 people at a time. How does the model change? So your base model again was this right here, right? And then now everything stays the same, right? 10 cents still, because I didn't tell you anything that changes of that matter. Your growth rate is still at 3. To the I minus 1, but now the summation says that you start at 20. So this again is a manipulation type of question you're answering, right? It's going off the base model. They tell you that the growth is still the same at 3, and you're still making 10 cents per person, but now you doubled whatever the first day post was. So it's 20 in this case, okay? And that's all I'm looking for right there, not calculating or anything like that. Whereas question 4, it tells you that, Suppose for the third month, research suggests a published post reaches 4 new people the next day. So that means instead of 3, you're going to 4 now. 4i to the minus 1. But then I also say, suppose for the first day, your published post reaches only 1 person. So now we go to from 20 to 1, right? And this is how your model changes. 1 to n, and then remember, you're still multiplying by 10 cents there. So these are the types of questions where I can ask you to manipulate your model based on, hey, your research is suggesting that you're going to have an uptick of growth here because of whatever reason. Or, hey, you know, we just already forecasted that something popular is going to happen. So therefore, you're going to probably get more hits, likes, views, whatever for the first day. Or maybe there's something that's going to happen. People are going back to work now. It's no more coronavirus. So the activity will be a lot lower for the first day as expected for the first month, right? The other thing I wanted to point out is that as you're going through this, yeah, I may have done this a little bit quickly, and it's also a combination of not being in person as I'm waving my hands, dancing around, doing jumping jacks, whatever, trying to convey this idea to you is that here with the summation, despite it being something new, it's a lot less busy work, right? It's way more theoretical in the sense that it's thinking about your ideas and bringing it all together. And it's not to say that your previous homework, for example, doesn't do that. It's just that that's more rote. It's more algebraically working or heavy, if you will. There's less physical work, right, or writing, but it requires a lot more thinking at a higher level to bring it all together. So those are generally the two primary differences that when you have a modeling, if I want to make it super hard, I have summation plus algebra right there. But most of the time for practice purposes, I isolate them, right? I have something that's more algebra heavy versus something that's more summation heavy, right?